For Unit 9, Objective 6, we're going to use the 3 laws of logs that we learned in Objective 5, but we're going to use them to help us solve log equations. Now, there's pretty much 3 types that you're going to see in this worksheet. You're going to see some problems where the left-hand side of the equation has a single log on it, and the right-hand side also has a single log on it. So I'm using problem number 3 as my example of how you would deal with an equation that looks like this. But before we can get to what you're doing, we're going to have to use law of logs number 3 in reverse. And we're going to take that leading coefficient of 2, and we're going to put it back to where it originated, which was up there in the exponent. So I'm going to rewrite the problem as log base 8 of x squared equals log base 8 of 100. Now, I have a problem that has a single log on the left and another single log on the right, both written in the same log base. So what I can do is their equivalency. The fact that they're equivalent lets me do that. I call it canceling both logs, but it really isn't. But since they are equivalent terms, I can just drop the log base 8 on both of them and finish off the problem as x squared equals 100, which means x would equal the square root of 100, which is plus and minus 10. Now, I got a little problem with that answer. We cannot take the log of a negative number. So the negative 10 actually goes out, and the only answer we really have is the positive 10, not the negative 10. A second type of problem you're going to see in Objective 6 is, what if the left-hand side has 2 logs and the right-hand side has 1? Well, we're going to have to condense the left-hand side first before we do anything else. Now, since this left-hand side is 2 logs being subtracted, then we're going to condense it to be 1 log using division. So I'm in log base 10 because you don't see any base. So I know I'm in log base 10, and since these 2 logs are being subtracted, I'm going to make a fraction out of their terms. So it would be x over x minus 5 equals the log of 6. So now I'm back to the situation I was in the previous problem. Now I have an equation that has a single log on one side and a single log on the other side, which enables me to see the equivalency of the 2 terms and just complete the problem without the logs. So I would simply have the equation x over x minus 5 equals 6. So now I just have to do some algebra. I'm going to cross multiply 6x minus 30. Got to distribute the 6 to both the x and the minus 5 equals x. I'm going to subtract this x over here. But that means I'm going to have to add the 30 over there. I need my x's on one side and my constant on the other. So I'm going to end up with 5x equals positive 30, which means x equals 6. Divide both sides by 5, and you get x equals 6. The third type of problem you're going to find on Objective 6 is problems that have 2 logs on one side of the equal sign, but the other side, there isn't a log at all. It's just equaling a constant. So what we're going to do on the left-hand side, we're going to simplify or condense these 2 logs into a single log. So this would be the log base 6 of, now since these 2 logs are being joined with addition, what I'm going to do is I'm going to multiply x times x minus 5. So I'm going to get x squared minus 5x equals 2. Now, since I'm at a point now where one side is logged but the other side isn't, that's going to force me to go into exponential form to solve the rest of the equation. So 6 squared equals x squared minus 5x. So 36 equals x squared minus 5x. It's a quadratic, so we're going to set it equal to 0 by moving the 36 over to the other side. 0 equals x squared minus 5x minus 36. Now the next thing I'm going to do, I'm going to factor this. So it turns into, if you're used to diamond factoring, great. If not, you probably know how to factor this. I'm looking for multiples of negative 36 that add to give me a sum of negative 5. And so the answer is negative 9 and positive 4. Negative 9 times 4 is negative 36. Negative 9 plus 4 is negative 5. So that gives me factors of x minus 9 and x plus 4 equals 0. Now, if those are my factors, then my solutions are x equals 9 and x equals negative 4. Okay, now let's get back to the rule of if you plugged both of these in one at a time, one of them would not work. Like for instance right here, if you plugged the negative 4 into the x right there, you'd be trying to take the log of a negative number, and we know that can't happen. So the negative 4 gets thrown out as an extraneous solution, and x equals 9 is my one and only answer to that problem.